So, welcome to the Chaos Communication Camp 23 again. This is the Bits and Bäume stage. And we have the next talk happening over here about open hardware and solar energy and Open-MPPT project. And for that, I would like to welcome the Elektra Wagenrad.
Correct.
From Berlin, who is active in the local Freifunk community for a long time there. And
20 years.
20 years. And we will have some short Q&A in the end. The talk is 20 minutes. It's in English. There's no German translation. Sorry.
Thank you very much. Thank you very much for coming. So as this is a short talk and I have 16 slides, it also comes down to what you know about the project. So it's an open software and open hardware project that you should be able to build yourself around the planet, and it should help you in many situations where you need independence from energy. It started in 2017, during the time when Freifunk was supporting refugees in the refugee crisis, where people were living in informal camps and they had no electricity and they had no communication, basically. So we were thinking, how can we bring to informal refugee camps in the field somewhere solar-powered energy and solar-powered connectivity? We were mostly concerned about the connectivity, setting up independent wireless routers. That's how it started in 2017, and the project has evolved quite a lot. There's now 3 different devices that I have engineered over time. So it started in 2017, Mark I. It is a 50-watt peak maximum power point tracker. Who of you does not know what a maximum power point tracker does? All right. I will be brief, but it's a complex subject to explain. If you run a solar module, you have a certain voltage where the module creates the most power, where the power output of the solar generator is the most efficient. If you connect it to a battery in an autonomous system without a maximum power point tracker in between, the battery will just suck down the generator to the voltage of the battery while it is charging. Which means, for example, you have a panel that produces 30 volts at maximum power, and you connect it to a 12-volt battery, and then the voltage in the solar panel drops down to the level of the battery. So, and the current, amazingly, stays almost the same. So if you could harvest 30 volts and 1 ampere, you will harvest 12 volts and a tiny bit of a little more amperes. So you will lose a lot of the power. And the maximum power point tracker can help this. It can detect at which voltage the generator is the most happy and can produce the most power. And then it uses a step-down converter, in my case, and tracks the voltage of the solar panel so it stays in that maximum power point, and then transforms it down to the level of the battery. And the result is that the current that charges the battery is increasing. Like in a 30-volt panel, it can be more than double the current that comes from the solar panel. So what you see here is Mark I, actually the first prototype. I've etched it myself, and of course you can find the files on the internet. And actually, if you have a workshop and you know how to etch PCBs, then you can etch it yourself. You need a drill and a soldering iron and the components. You download the files. You print them on a laser printer. You use them to expose it to photosensitized PCB material. And you can etch it yourself. Or you just order PCBs from a manufacturer. So Mark I was designed to be used in combination with a wireless router running OpenWRT. The idea was to make the smallest and cheapest solar node that is energy autonomous for an entire year in the area of Berlin, for example. and you can monitor it from afar. So you deploy it somewhere, and you can connect to that OpenWRT-based router, and you can read the data from the maximum power point tracker. You can check the charge of the battery, and so on. In 2018, 3 people, including me, we got a grant from the Prototype Fund in their 3rd round, so we could work on a web app and other software in OpenWRT, Lua programs to do this monitoring and data aggregation. And that program needed a name, so it was called ISIMS, Independent Solar Energy Mesh System. So this is how we figured out would be a good way for such a mobile disaster recovery node. A solar panel at the ground, a telescopic mast, and on top a waterproof router with Wi-Fi and mesh compatibility. On the right side you see a little screenshot from the app, and it shows you the situation of that node. It's a node on the roof of my hut, and it's just showing the system is fine. It is supposed to give information that even if you're not too technically skilled, you learn something about the health of your system. And then came Mark II. I thought to further reduce the cost for some situations, for example, you live in a village that is cut off from the internet pretty much, and there's a hill in between you and another place where you can get internet from via wireless. You could use a device that is based on the ESP32 chip that has Wi-Fi on board as a Wi-Fi relay. So it became optional to add that OpenWRT-based router because the 2nd generation became self-sufficient with regards to Wi-Fi. It cannot do completely mesh networking. It can do routing now, but it doesn't need the extra power to power an OpenWRT-based router, and it still gives you some megabytes per second in relaying traffic between 2 places if the RF signal is strong enough. Are you okay? I hope I'm not boring you at all. So, and then people came and said, well, that ESP32 chip that has the Wi-Fi on board, it has many unused GPIOs. Please, why don't you expose these? We could use it for sensors and for whatnot. And people were asking, hey, why do you only want to power wireless routers? We need more power, give us more power, which was out of the scope of what I initially intended to do with this project. But I said, okay, well, it opens up the possibility to use it for other things as well. Sensors, you will see a few examples later. Why not? So I extended the design, added 1 more pin header, and increased the power. I doubled it basically. But this wasn't the end, because people were saying, why only 100 watt peak? We need more power. Initially I had thought, okay, there is commercial maximum power point trackers on the market that you can buy from companies. I don't mention those companies. But of course there's a virtue in having an open source and open hardware project that you can extend and hack on. The devices, since I use the ESP32, you can telnet into the machine. Sorry, no SSH, but you can telnet into the machine. You can FTP programs into the machine or download it from there. You have, of course, a website, you have a web interface, you have MQTT protocol as a telemetry. You can configure it that it sends to 2 MQTT servers its data, so you can monitor it from everywhere and you can run your own server to monitor it locally. And of course, since the device now expanded to a device you can also use stationary. I also added the option to have a display in the 3D printed housing, so you can also 3D print your housing. But please use flame retardant PETG, because it's strong electronics, high currents. In the worst case, when you have like full power from the sun coming in and full power demanded from the battery, it can deliver up to 50 amperes to your consumers. So that's a current you can use for welding. Yeah? And the peak currents inside the device, they can go to 30 amperes at 400 watts peak. So that's why you see this massive inductor coil, which is used as the transformer. Prototype number 2 of this device has been tried in an experiment in Ant Hill in India. Because what can you do with 400 watts peak solar power? You can run a small server and have a community that doesn't have internet access and give them local services, like local Wikipedia, local video streaming, and whatnot. So this is another nice addition. The software running on the Think Center is Nimble, is another project. I don't know if Eric, who is involved in the project, is around. 2 pictures of India, from India, and also pictures that I'm going to use in the printed documentation, how not to use the device. The people in Ant Hill, they have built a bamboo tower with a metal housing where the sun is blaring on that metal housing. And they have put the batteries into the metal housing to make theft of the batteries more difficult. But at the same time, they are frying the batteries. And they're also frying my electronics. The device is supposed to be mounted upright, so you have some cool airstream to cool that powerful inductor. Because at full power, only the inductor can produce 5 watts of heat. And that heat has to go somewhere. It's not supposed to be accumulated in that housing. And then people came again and said, you know, why not build a device for watering plants independently? So I built a prototype based on the 100 watt version for irrigation. So it measures humidity of the soil, it controls water valves, it controls a pump to provide water to the system, and it also has a tank gauge to measure the amount of water that is remaining in the tank. And of course, it sends everything via MQTT protocol to the service you like, so you can monitor it. I think this is quite helpful. At the moment, it's a prototype made with wiring on an existing device, but I consider also making a PCB for this purpose. Just, in last autumn, I took these pictures. These are drop irrigation outlets. You can save a lot of water, and you can treat your plants really well with this. I learned, I'm not too much into gardening, that you should water your plants about 1 hour before the sun goes up in the morning. That's the best time, where you avoid fungi growing on your plants, and the water is used most effectively. And in times of drought, that might be a really good thing. So, I promised not to talk too much and spend too much time. So, I thank you for your interest. And now we're ready for questions and answers.
So we have some questions. So raise your hand that we can see you, and then we'll try to accommodate as many as we can in 5 minutes.
Hi. Are the design files or the schematics for the Mark II or Mark III available anywhere?
Mark II is available at electra.info, and then you go to the site and you go to FF ESP32. I have not published with Mark III because I'm not completely done with the development yet. And if you want to produce them, please contact me for the latest files and also the support with some of the components. Because, the chip crisis and the resource crisis also hit me. I'm still waiting for some power inductors for like 2 months now.
Over there to the back, yes. If you raise your hands a little bit earlier, we can be prepared to where we need to appear after. And you have to talk because it's a long way for the microphone to reach the next question. Sorry. And there we go.
Hi. First of all, thank you for all of this. I have a good idea about what an MPP tracker is doing, but I have no clue how it's been done. How it is doing it. Could you maybe elaborate a bit on the implementation and how you specifically achieved this?
Do you know what the DC-DC buck converter does and how it works? So basically, you have in a standard DC-DC buck converter, you have a feedback loop that controls the output. And there's just yet another feedback loop which is controlling the input. So the pulse width modulation is controlled by the voltage at the input and finally when you reach the charge end level at the output. So because a standard buck converter, you can try this. Without such an outer feedback control loop, it will just try to suck as much current as it gets, and then you still have the same effect. It's even worse than just connecting your battery to the solar panel without a DC-DC buck converter in between. Other than that, of course, it's a solar controller as well, so it protects your battery from overcharging and deep discharging, which would damage the batteries. Oh, what I forgot to mention, so far I have been using AGM LED batteries, but at the moment I'm working on LiFePO, so lithium iron phosphate batteries, and modify the charge controller for this in the software. I don't need to do anything in the hardware.
Are there any questions? More questions?
I see this guy.
Over there, yes. It's
what is the voltage for the batteries? Can you configure it, and in which range?
It's a very good question. No, at the moment it's 12 volts, so you can charge up to 14.7 volts, and you can control it from software. So use the chemistry you like. If I would make some changes for 24 volt systems, then the power capacity would double also. But I'm personally using systems like these, and I prefer having a single 12-volt battery rather than have several in a row. But I know many people are saying, why not get 24 or 36 or 48 volts? But at one point, I'm going to do it probably. And of course, the challenge for people asking, hey, why only 400 watts? It continues.
Numbers. Okay. Anyone else? Otherwise I would have a last question then, but go. Or tell if it's, sorry. I would repeat it otherwise.
One very short question about the autonomy of your project in Berlin. You told you can reach about 100% of autonomy. Which calculator did you use for that assumption?
Oh, there's a manual. When you go to the Electra site, there is a big manual. It's 52 pages. And I'm trying to cover, not everything, but as much as I can. And I like a printed documentation. Of course, it's a PDF. You can print it out, whatever. Maybe I'll publish it as a book and people can buy it to support me. Sorry. I'm lost. Say it again. The calculator. I used, there is some global irrigation calculator and a very conservative estimate of the storage for these dark times. But it might, the weather changes. If there is 3 weeks of absolutely no sunshine where the cars drive at noon with the lights on, then of course it could happen. So I cannot guarantee 100%.
And okay, so I have also a question. So commercial MPPTs are available, of course, but they are quite expensive too. And if I want to use it with like low power solar batteries that I get often from second-hand market or something, it's not really feasible. So how much is an invest to build OpenMPPT or like cheaply?
You mean the biggest one, or just you pick the size that you want? When you build it on your own, the question is how many are you going to build? Are you just building one or a few? I think if you order them in China, you can have them made in China at companies like don't mention. Then it's fairly cheap. But of course, you have to do some assembly. They would not do through-hole assemblies, and you have to do some initial programming and so on. Probably for the 100-watt version, maybe 35 euros. All in all. Thank you very much.
Thank you very much. And that's our time.
Thank you.